Hello and welcome back to the Elm Goose-Driven tutorial. In the previous parts, no geese were drawn, but in this part we'll draw a goose, and I promise that. But let's do a little bit some fun with what we did in previous parts. I forgot to try this thing, for example, to replace the goose with the proper character, but that's not what I wanted. Still I did. I wanted to create the polygon renderer since we did the spiral renderer in the previous part, and if we think about it, that the spiral places the items around in the circle, and if we have a polygon, and then we have the vertices in the same points where we have placed the items. So let's just do the polygon render before starting and doing something with images, just to demonstrate to you the concept and something harder to draw than just the images symbols or the symbols. Let's just maybe copy paste. No, not this time. Let's define the type first, which will be just that. The type constructor has the same name as the type, and it has just one argument, which is the number of vertices. Sorry, I can consult Google on that. Not now. And not I can consult Google, but Google can consult me on how to pronounce the different words. So the renderer for polygons. It accepts the matrix and it accepts the polygon, and we want to extract the number of vertices from it. So we will need to draw a path to use this render. Let's just return the empty list for the moment and prepare our thing, change it from spiral. I really want to just comment it, maybe we will reuse it later, but usually that happens. It goes different ways, but usually you comment things and just the comments are there. Let's begin. So let's render the polygons in the list. No, not this way. It will be list renderer, and it accepts the polygon renderer, and we give the metrics and translate it a bit. And we give the list there, the actual list of values of polygons. And for now, let it be polygon with 3 vertices, polygon with 4 vertices, and polygon with 5 vertices. We'll change it later. Sorry, this is transform, of course, and this is as well transform. It's just usually I import that as M. Since we don't render anything from this polygon renderer yet, it is just empty here. And now we will implement the polygon renderer very close to the spiral renderer. We use the canvas shapes function for that. We shouldn't forget to apply the matrix to keep all the transformations there. And here we have to provide the path which consists of the lines, and it's this usually like that, and the point, the origin of the path, and there go segments, but we don't have them yet. But we have the same way as before, the radius. Don't go inside in any way, so just radius, and also the angle coefficient, which is now the distance between the points, and it is just 2 pi divided by number of points. Oh, I will say points. And we need some function to get the position of the point, and it's very similar to what we had here, like we translated the metrics here, and we've passed the coordinates to the translate function, and now we just need the coordinates. And we have the index, and so for x value, I'll keep some space for y value. For x value, we multiply radius and cosine of index multiplied by the angle coefficient, and almost the same for y, just replace it with the sinus. And we don't use that function yet, and now we will. We just need indices here, so first we will produce the list from 0 to n. Then we will there will be just integer numbers, I suppose. Yeah, integer from 0 to n in this list. So we have to convert them to float. Then we convert every float value to the pair of coordinates x and y, and then we pass it to the canvas line 2 function. And here we have the polygons. We just want to probably configure how they look. Let's fill color black. Example, we haven't imported color. We will. Color. Oh, we haven't installed the color. Install. I suppose. What was the name? Sorry. AVH4. This is the user who created the package. Yes, we just want to move it from indirect to direct dependencies. Hope it works now. Yes. So we fill it with black color, and this is because I want to show you something. And the stroke is also black, and the line width is 5, and for that we have to import settings line is, let it be canvas. So if we hide the fill, okay, if we should have, why does it compile but looks still the same? Maybe because the fill is black by default, but there was no transparent color as I recall. Wait, no, it doesn't change. What is wrong? What is wrong? Probably because we have installed the package something desynchronized. Let's start it. What? No, I don't know. No, I don't know. Not now. Let's restart it. Somehow, sometimes it happens. And yes. So you see, we have this line here, and which way we will solve it? It is because this coordinate is where we move to. It is before drawing all these lines, and we will just replace it with a call to the point for function for the point of index 0, and now probably we don't need is the 0 point here, because we move the line to this point, but in this case we probably want to close this gap, yeah, this way. And actually those functions can be just combined in one. No, in the direction is wrong, because those arrows were in different direction. So that's it. That's the polygon renderer, and maybe we will use it later. Let's draw some more polygons and use the same list range function for that, starting from 0. I will not make it to 10 but then we need to map it polygon function. Here we go. It is not in its full. Let's change it to 90. Oh, not by y axis, but here. It's here. We have it. Let's get the black fill back. Come on. Yes, that's it. If you make them closer, they will look like shashlik, if you know what I mean. Yeah, this way. Perfect. I'll make this screenshot for it. Maybe we need some more colors, but not in this part. So sorry I took kind of 20 minutes of your time to create this thing, but I suppose it will be handy. And now to the images and to the geese and to the goose. Now we will finally replace this update function with something meaningful, because we introduce some messages in our application. But let's start from what we do at the start of every part of this tutorial, is to change renderer. Now this is not only accepting the metrics, but also the list of textures, the dictionary, the hash map of textures. I want to reuse this type name, so it will be alias, and it will be the dictionary from the string to the texture. for that we also need to export the I suppose it's not in the settings, texture, canvas, and import dict exposing dict. So this will be the alias for the textures. We'll keep them all in one dictionary. This is actually the physical texture, the image, and this will be the alias for this image to reuse it. Maybe let's create some type that will hold this value, just for us not to mix it with other different strings. Maybe image alias that way. Yes, and so now every render will accept the dictionary of the textures we have, and this one doesn't need it, this one doesn't need it. What is the problem? Matrix. Oh, I messed something up, right? No. Matrix. Maybe. Oh, string render. Yes, it now needs textures, and all the renders need textures now. So we will pass them inside textures, 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 textures. If we wouldn't have this thing in the end here, we could have get rid of this and write it shorter, but our case is different now. And again, textures, textures. I think this is the last change. No, if we do animation, there'll be one more change, because we'll need time. What is the problem? And because we don't have the textures here, and the textures, and the textures, and the textures. In this case, people usually use it is before the matrix multiple cursors, but not me. I do every change by hand. Textures before matrix, textures before matrix. Textures here. Also, we can write some converter for the renders from one type of render to another. not to do the same, not here. How many renderers we have here? It's just 1 minute of replacing. List renderer, item renderer, textures, textures, textures. Maybe I should have done it different way. I wasn't aware of consequences. Textures. Will you be satisfied finally? Textures and our polygon render, the last one, textures, and it doesn't use it. Not, and the case where we use the render also needs textures. What is wrong with that? Oh, just the name, because we don't have textures yet, right? So we just pass. This is the root of the thing, so we just pass the empty dictionary yet, and we have if we forget about this, I will not. So the update function, no, where to start? Now we change our canvas call to the to a little bit other call, which takes the arguments, as you may see, differently, because now it includes textures, and now it doesn't use the tuple for these arguments, but the record. How much was it? Let's make it as before. 700. And textures. And for now it's the empty list. And now these are different textures. So we create the list. I have some files with the images. First I probably have to I moved those files from other point. What is the name? I don't know what is named here, but the only one is of course the Highlander, and we have the goose, so you see where it goes. Maybe we'll need to restart the server again, the Elm Live server, so that it could pick up the assets. Yes, and then let's continue our journey. Now this comment. Let's move it somewhere further, not to distract me. let's name the list like textures to load, and it will be the list of the textures to load with their no, we do it this way. This is the way, which will contain the path, assets, goose, PNG, for example, for now, and the alias for the image. And now we provide the canvas here, the textures we want to load. But also for these we need the message type. That's why we do it so lately, because it required a lot of coding, more coding than before, but not that much. We need the message, which will be passed in our update function, since now we have something asynchronous, and now we actually change the model. Even we had nothing asynchronous, but if we change the model, we have to have some message type. Am I right? Maybe. Texture, and the message which will hold the actual texture. And did we import that? Texture is canvas. Okay, let it be canvas texture. Canvas texture, and also the alias of this image. Maybe it should be not image alias but texture alias. Replace image alias with texture alias. I'm just checking all the letters, right? All right. Now we have the list of the textures and some messages to produce when we successfully load them. Of course, we will. So we take this list of textures to load and map it to some special function. First, we wrap the second part in our special texture alias type so that it will be packed on the next step. And now we pass it to the function, like every element in the list, which gets the path and texture. Is it txt? No. Texture as. Let's write it the full way. And I have some example here. I will just copy paste it, and not to write for a long time. We use this load image from URL function, which accepts the path and it asks us for the messages to fire. Those are like events when the image was loaded or failed to load. So when it succeeded, we'll get the got texture message in our update function, which is not ready yet, but we will. Or if it failed, we will just skip this, ignore this fact. We will be ignorant. And so our model is a bit different now because it should store textures. And the question is, do we want to store the thing we draw in the model because we don't change it, and till that moment we just write it in line here? So maybe our model then will be just the textures dictionary, which is a dictionary from the texture alias to the actual texture, if it's there. If it's not yet loaded, then it will be empty. So our model is a dict now. Maybe it's time to write some types here, and now it's the model is textures and the messages is our messages, and our custom update function now, which accepts the message, the previous model, which is textures, and returns the new textures. Message, textures, and return. In case the message is no op, we just return the same textures, and if we got texture, we have the texture ls. This is one of the rare reserved words, the ls, so we name it longer, and the texture itself, and if we got it, we insert it into the dictionary by that alias, this texture. Okay, it should be string there because we have to have the comparable type as the key in our dictionary. It is one of the rare downsides, maybe, of Elm. It's not that important. We can deal with that. But you cannot use the non-comparable types as the keys in the dictionary. So we had to unwrap it and insert the string here. So this is our update function now, and it even works because we do nothing with the draw canvas function. We just pass. I didn't forget the empty dictionary here. So we will take the textures argument here and pass it to the renderer, and nothing happens because we don't use them. So to explain it quickly, here on every render cycle, we ask for the same thing, you may think. And you may think that it's very inconvenient. Why would you ask to load the textures every time? But I suppose somewhere inside it just checks if it loaded on every cycle, if the texture is already there, so it's not doesn't affect the performance, and also some functional stuff happening here allows us to do it on every cycle. And here we receive the actual dictionary of the textures. Let's finally give types here. Textures, and this one is HTML. Now we just need the texture renderer. Let's name it image renderer. Image renderer, which is the renderer that takes the texture alias and renders the corresponding image. That easy. That easy. And what it does, it gets the dictionary of all the textures here, because again, if we unwrap this type, let me repeat it, we may replace everything with its definition. For example, if we have the access to the fill function, we just may put the code of the fill function here, or here we have some code for the apply function. If we just copy paste the body of the function and put it there, it will just work. And the same for types. Just if we just replace the thing, it's just the shorteners. So it accepts the metrics and the texture alias, and we look into the dictionary. We have to unwrap this string value texture alias. We look into the dictionary texture alias, and if we have the texture, we render it. We will, and if there is no texture, we do nothing. Case is the problem here. Okay, we have redefined the maybe type here, and we have the conflict due to that fact. So we just call the texture function, position it at 0, 0, pass the actual texture there, and here we apply the metrics, and that's it. Let's try it in action. I'll just replace this one with the image render. Let's do it this way. Image render, textures, and texture alias goose. That's it. Finally, we got our goose here. Isn't it fancy? So I promised, and I did it. This one is not drawn by me, but I thought it's cute, and I even did the vector version of it. Not this one, sorry. This is the official one. This one. So we no. Let's name it Goose Drawn, and now we have no textures, no matching textures, and load both of the images here. Yes, this way, and now we will be able to switch it this way. Yes. Okay. What can we do with it? Like I suppose we have 10 minutes or so to make this part also long, an hour long. And I want to recap quickly. What we did is we changed the model of our program. Now it's the dictionary of textures. Normally, what we draw should also be in the model, but since we don't change it, we don't need it in our case. We defined our own update function. Finally, as usually we do with the Elm applications, it accepts some messages, which is just the type. You may name it not the MSG, but something different, anything you like. Event, action, whatever. Um, it gets the previous state of the model and returns the new state. And we've added this part of code here, which we will probably move to some separate function because it looks a bit ugly. I have problems with English pronunciation. Um, and they become more serious with the age. So I keep being positive. uh, so yes, textures still odd. We pass them to the special function, which actually triggers our messages or actions or events when the images are ready, and that's it. And if they're not, it triggers the no op message, which does nothing. And we wrote our own image render. Let's scale this thing. Scale 0.5, 0.5, for example. Oh, yes, it should be the matrix itself. So it scales. It scales. What if we return this spiral renderer and try this with the goose? I haven't tried that. I have almost everything prepared, but not this. So if anything goes wrong, don't blame me. I'm just a risky person. Textures. The previous variant works. Sure. Whew. What was here? Whatever. Texture. No, it shouldn't be. Maybe render now. Texture alias. Goose-Driven. Oh, we got a lot of geese. This is quite a crowd. They're not again, we don't rotate every goose. Why don't we? This is the matrix. Let's try to rotate one. Rotate degrees a little bit. Oh, they are all rotated because it doesn't add to the rotation, and to add to the rotation we need to change this matrix. Yes, now again, what we've tried to get rid of, I want to get it back to add the rotations. If I put it here, it will be the same as here. Render items, index, m, matrix. Let's, for now, we can pass the matrix here, another one, and then combine them, join them together. But let's do it different way. We'll pass the angle here in this function, and we will increase it item renderer. So we will need to apply it, transform, rotate degrees. Oh, sorry, of course, angle, and here we add some, for example, +5. Yeah, yes, now they're different now. Maybe we should rotate first and transform later. We may pass this angle here. I will remove this code because it complicates the spiral render, but it's just for tryings. Rotate degrees angle. So yes, now it seems it's the same. If we rotate first, or if we don't, or at least it's similar. Still funny. Still funny. We have different textures out there. Let's move it. But we'll show them in the next parts. Because finally I kept my promise. and this is the Goose-Driven tutorial. You have geese. What if we... I almost said bye, but let's try the goose from the logo. And of course it works with our different complicated types with trees and everything. We'll try that in the next part, and we'll try to do some animation there as well. So thank you for the attention. Bye. Till the next part.